Hello everyone, my name is Hailin. Today I will be presenting you with a dog with image classification. So let's begin. There are two main reasons I want to start this project. One is to enhance my knowledge in deep learning and to practice TensorFlow and Keras library. Also, I would like to go through the process of building a model from scratch and understand how it works. The second main reason is that in the future, I'll be adopting a puppy. So getting familiar with the breed and understand the difference will definitely be helpful to me. So here is my technology flow. I got my dataset, which are image from Stanford University. Then I pushed it to Amazon S3 bucket and load all image from Amazon SageMaker. After I got my environment set up, I have load all necessary library, including TensorFlow and Keras. And then I will just begin my project. So here's my data set. My data consists of 20,580 images, include 120 brief and 9 groups. The groups do not come along with the data. What I did is basically I manually clean the data and classify each brief into 9 groups using Megan Kino's groups definition. So here's some of the example of the image, and here's the group of the puppies. So convolutional neural networks. So what is CNN? CNN consists of 3 parts. The first part is convolution, known as filter. This step will scan through the image and try to detect edge and shape. So you can imagine that as a human, similarly, we'll try to identify the feature from an object to tell what the object is. The next step is pooling, which to get the most important feature and reduce dimension of image. Similar to human, with this 4 image here, we may able to tell that it is a puppy. And the last step is to generate output, which to classify the breed. So for this project, here's my structure for my CNN model, which consists of 5 layers. And as you notice that we can have multiple layers of filter and pooling in between. And the last layer will be fully connected and then generate the output. I also apply a transfer learning model known as Inception V3, which a pre-trained model over 1 million of images developed by Google. It is a step layer compared to the traditional CNN, and it is up to 48 layer. So here's my CNN baseline model with 3% accuracy of 120 brief, which are still better than the random case. The 9 group classification has 26% accuracy, but due to the space limit, I am only showing the confusion metrics for the groups, which we can see that many groups are being mislabeled. So we are not happy as this puppy is right here. So after applying a transfer learning technique, we're able to push up the model from 3% to 70% of 120 brief, and from 26% to 72% of 9 groups. The confusion metrics improved significantly, but we still have the problem with Terry and Hans groups. But we're still happy, like this puppy right here, at least our model improved it significantly. So here's one of the examples that the puppy being misclassified. So we can tell that even as human, we can tell these 2 puppies look somewhat similar, which makes sense that our model predicted wrong. So here's the puppy from our classmate about to adopt. As you can see that different angle of taking the image will affect the prediction too. And also this puppy is not included in our data set, which is almost impossible for our model to give a correct prediction. But from a business perspective, that we may able to tell it is a mix. And the truth is, it is a mix. So lastly, the challenge we have that we have a small sample size in terms of image. So we should consider increasing the amount of image in the future for better accuracy. And the second, we have a surrounding feature that are not helpful to identify the puppy feature. And the last one, there's no standard in terms of features, such as the proportion of puppy will change over time. Like the year of puppy will grow bigger. So that will also affect our model. So in the future, I will definitely love to improve the model and adding more functionality, such as identify the image is a puppy or a kitten. So here's the end of my presentation. Thank you for your listening.